All right, seventh graders, going to keep going with our fractions. So we're going to talk about adding and subtracting fractions. And I kind of touched on this last time, but we can convert mixed numbers into improper fractions. So a mixed number has a whole number and a fraction where your numerator, so again, real quick, fraction has the numerator on top, denominator on the bottom, and in a mixed number, the numerator for your fraction, your numerator is always smaller than your denominator. Whereas when we look at an improper fraction, it's just a fraction, but your numerator is greater than your denominator. So you don't have a whole number in this case. So we'll do some examples and get into it. Find there's some or difference, simplify if possible. You cannot add or subtract if you don't have the same denominator. So you need the same denominator to do this. So if I have the same denominator, I add the numerator, keep the denominator the same. So let's kind of put that in words, okay? Add the numerator, keep denominator same. And we all know that 1 plus 3 is 4. So we have 4 over 8, but we can simplify 4 over 8 because they both have factors of 4. So we get 1/2. So our final answer would be 1/2. Now again, even if it's a variable, I still have the same denominator. So I can keep my denominator the same, subtract my numerators. 9 minus 7 over x equals 2 over x. Because I don't know what x is, there's no way I can simplify. That's as far as I can go, because I don't know what x is. Now, this part gets a little tricky because I don't have the same denominator. So I have to do some side work and say, what can I find that's common between these numbers? And I want to try to find the smallest one. If you find a larger one, it will still work, but you'll have to simplify. So I see, hey, they both have a factor of 24. So I'm going to take 1/8 and I'm going to multiply the top and the bottom by 3 over 3 so that I get 3 over 24. Then I'm going to take 5/6. I'm going to multiply the top and the bottom by 4 so that I get 20 over 24. Now I'm going to line them up, and now I can actually add them because I have the same denominator. So 3 over 24 plus 20 over 24 equals 3 plus 20 over 24, which equals 23 over 24. And I can't simplify that. Oh, Mr. Larson, you made a big mistake. It said subtract. So let's redo this last part. That's how we would do it if it said add. 3 over 24 minus 20 over 24. So I'm taking away the larger number. So my answer is going to equal negative. So it's going to be 20 minus 3, which is 17, but it's 3 minus 20, so my answer is going to be negative 17. And I keep 24 the same. So negative 17 over 24. All right, very similar. Don't have the same denominators. Good news is we already figured out what is common. So I'm going to set it up. 1 over 8 multiplied by 3 over 3, 3 over 24, and then 5x over 6, 4 and 4. 5 times 4 is 20x. 6 times 4 is 24. So when I write this, 3 over 24 minus 20x over 24. All I can do is put them under the same denominator, but I can't do 3 minus 20x because I don't know what x is. Again, if we have something that we don't know what it is, we can't just make something up for it. So that's as far as I can go. Ollie hiked 2 2/3 miles near Mount Shasta, and then another 1 3/4 miles to his campsite. How far did he hike in total? So notice we've got these mixed numbers, so we'll deal with those, and then we also have to deal with the fact that we don't have the same denominator. So 2 ways to do these. We'll do it one way on this example and a different way on the other example. So to start, I'm going to add my whole numbers, and then that's step 1, and then step 2 is add fraction. So step 1, whole number of 2 plus 1, I'm going to get 3. Okay, sweet. Step 2, I got to find out what is common. So we have 3, 6, 9, 12, 15, 4, 4, 8, 12. Hey, I've got a 12 and a 12. So I'm going to rewrite my fractions as 2/3, but I need a 12 on the bottom. Gives me 8/12. And then I'm going to do my other fraction, which is 3/4 times 3 over 3. You get 9/12. So when I add these up, I'm going to get 8/12 plus 9/12 equals 17/12. Notice our denominator is smaller than our numerator, so we got to take out factors of 12. So how many times can I take out 12? Well, that's just going to be 1. So adding the fractions is really like saying, hey, this equals 1 5/12. So now I got to take this answer, take it all the way back up here, and add it to my whole numbers. So 3 plus 1 5/12 is going to equal 4 5/12. So he hiked 4 5/12 miles. That's a lot, but he's tired. So I said we would do this one first, or differently. So the way you do it differently is you take the fractions and turn into mixed numbers. Into improper fractions first. And then you solve. So if I want an improper fraction, again, 2 1/2 is like saying I have 2 over 2 plus 2 over 2 plus 1/2. So that gives me 5/2. Another way you can think about it is you take the whole number, you multiply by the denominator, and then you add the numerator. So 1 times 4 is 4. 4 plus 3 is 7. Therefore, this number is going to be 7/4. So again, multiply the whole numbers. 2 times 2 is 4. 4 plus 1 is 5. So multiple ways to do it. So 5/12 or 5/2 minus 7/4. We do not have the same denominator. Luckily, we only have to change one of our numbers. We can change 5 over 2. I'm going to multiply the top and the bottom by 2 over 2. Get 10 over 4 minus 7 over 4, and get 3 over 4, 3/4. So this one was nice because I only had to change one fraction to get the common denominator. Again, key idea, adding and subtracting fractions, you have to have a common denominator. Have to.